Okay, so we're going to continue the example we left off on from the previous video, which was problem 8 in the homework for section 4.1. Okay, so part A asked us to calculate the mean, which we've already done in StackCrunch. Okay, so the mean, which is 0.556. Okay, when you round it to one decimal place, right, that 5 gets rounded up to a 6. Okay, so you may want to remind yourself how to round properly. Okay, but to round this to one decimal place, right, you find the rounding position, which is the first 5 after the decimal point. Okay, and if the next number over to the right is 5 or more, let it soar. So it means you increase that number by 1. The number of the rounding position goes up by 1. Okay, but if this number to the right is 5 or less, okay, if the number to the right of your rounding position it is 4 or less, right, let it rest. Meaning, right, if this 5 here were 4, right, then that 5 would stay as a 5. Okay, but in any case, the mean when it's rounded is about 0.6. Okay, next part says to find the variance. Okay, so you have to remember that the variance of a random variable, okay, is equal to the square of the standard deviation. Okay, that's what you have to remember, because if you look at the calculator, okay, the calculator doesn't give you the variance. It gives you the standard deviation, which is this number here. Okay. Now, it will ask you for the standard deviation. Okay, but unfortunately, it asks you for the variance first. Okay, so the homework is assuming that you're calculating all this by hand. Okay, which we're not. So if you're calculating this by hand using the formulas, right, you would calculate the variance first using this formula. Okay, and then once you have the variance, you can square root the variance to get the standard deviation. Okay, but we're kind of working backwards because StackCrunch gave us the standard deviation rather than the variance. Okay, so what you want to do is you want to use a handheld calculator. Okay, so type in the value for the standard deviation. Okay, so it's 0.94, 279, 584. Okay, so I'm going to type in all the digits that are displayed in the calculator in StackCrunch for the standard deviation, and I want to raise that to the second power. So however you're going to do that on your calculator, so on this calculator, right, this is the button you press to raise it to the second power. Okay, and we get 0.88888, and so on. Okay, and we're going to run around that to one decimal place. Okay, so that 8 there is in a rounding position. Okay, the next number to the right is an 8, so if it's 5 or more, let it soar. So this 8 goes up to a 9, and you ignore all other digits to the right of your rounding position. Okay, so the answer for the variance when rounded is about 0.9, or 0.9. Okay, and now we need the standard deviation, which we've already got, okay, which is 0.94. Okay, once again, it'll ask you to round to one decimal place. Okay, and notice that the variance, which is this number here, 0.888 on your calculator, and some other digits, okay, and then the standard deviation, which is 0.94, right, notice that they are different. Okay, but when you both round these, the standard deviation and variance, to one decimal place, okay, they actually look like they're the same, but they're not. Right, the reason that they look like they're the same, the variance and the standard deviation, is because we're rounding. Okay, but in reality, the standard deviation and variance are not going to be equal. Okay, so then it wants us to interpret the results in the context of a real-life situation. Okay, so I got to read the answer choices carefully. Okay, so another word for mean is average. Okay, and then the standard deviation is the standard deviation. There really isn't another word that we use for standard deviation in this chapter. Okay, so the average number of dogs per household is 0.6. Okay, and the standard deviation of the number of dogs is 0.9. Okay, so you're going to select the answer choice that makes the most sense, describing the mean and standard deviation. Okay, so answer choice A makes the most sense because it says a household on average has 0.6 dogs with a standard deviation of 0.9 dogs. So even if the numbers don't make much sense to you, right, this is the answer choice that makes the most sense for the definition of the mean as being the average, and then the standard deviation as being the standard deviation. So let's check our answer. Okay, so we can go to the next question. Okay, so question 9 is very similar, but it's obviously a lot longer. The table's a lot longer. It's got more values. Okay, so number 9 is similar to how you do number 8. So I'm going to go and skip over to it. Skip it. Okay, and let's go ahead and look at number 10. Okay, number 10 says, using the data below, determine whether it would be unusual for a household to have no high definition television. So HD means high definition. Okay, so this table is summarizing the number of HD televisions per household. Okay, in a small town, so it was found that in each household, right, they either had no HD televisions, 1 HD television, 2 or 3 HD televisions. Okay, so there are no households with more than 3, and likewise, if you don't own any HD televisions, it's not possible for you to own less than 0. Okay, so the possible values are 0, 1, 2, or 3. Okay, this gives you the number of households that have that many televisions, and then likewise the corresponding probabilities. So what we want to answer is, right, is it unusual for a household to have no HD televisions? So to answer the question, what does it mean for an event to be unusual? Let's go to the book. So you're not going to find the definition of unusual in chapter 4. So we're going to go all the way back to chapter 3. And we're going to go to section 3.1. Okay, so in section 3.1, we want to go to page 137. So if there's a specific page you want to go to in the book, right, you click on this button here, which is navigation, and then you can drag and drop this icon here, okay, to change the page number. So you go up, go down, or rather go up to go to previous pages, and then scroll down to go to later pages. So we want to go to page 137 specifically. Okay, it takes a bit of coordination to do that. Okay. And we've already seen this rule in section 4.1 where it says that probabilities are always between 0 and 1. Okay, and here you have a number line listing probabilities between 0 and 1. Okay, probabilities that are closer to 1 are more likely to happen. Okay, probabilities that are closer to 0 are less likely to happen. Okay, but what it says here, an event with a probability of 0.5 or less is typically considered unusual. Okay, so that's what we're looking for. So the definition of an unusual event, okay, which is an event with a probability of 0.05 or less. Okay, so that's our criteria for an event that has an unusual probability or an unusual likelihood of occurrence. Okay, so going back to the homework, okay, you can see that the probability that a household has no HD televisions is this number here, 0.010. Okay, so if you compare 0.10 or 0.01, sorry, 0.010 to 0.05, right, you can say that, or we can see that 0.010 is less than 0.05. Okay, so the answer is yes. it would be unusual, okay, because the probability of 0.01 is less than 0.05. Okay, that's what we saw in the book, so an event with a probability that's less than 0.05 is unusual. So select the best answer choice. Alright, and that completes question 10 and the examples from section 4.1. Thank you for watching.